So what we are going to learn today is called family of graphs. Family of graphs of the form y equals to a raised to ax raised to the power of n. Now n can take any number from, obviously it can take a 0 as well, from 0, 1, 2, 3 and until infinity. But we are primarily going to deal with n equals to 1, n equals to 2, n equals to 3, and n equals to 4 here. So when your n equals to 1, what would be the equation here? It will be y equals to a raised by x raised by 1. So which is y equals to a raised by x. Now the degree of this equation is 1. So when the degree of the equation is 1, the graph is a linear graph or a straight line. So if I draw a straight line on x and y, I get a straight line. Any straight line. And I can get a different type of straight line as well. What is primarily the difference between the two? The slope of this graph on the right, on the left, is positive. And here the slope is negative. So, and who decides the slope? What decides the slope? This A is the slope. My basic equation of the line is y equals to mx plus c. M is nothing but A here. So if c is 0, if I say c is 0, this line is reduced to y equals to mx. Correct? So mx is nothing but ax. So a and m are equal. So so a means the slope. Slope is positive or negative. Now so that's the basic graph of y equals to ax, a straight line with either a positive slope or negative slope. Now let's say n equals to 2. So what does my graph becomes? Ax to the power of 2. This is a quadratic graph. When the graph is quadratic, you get a parabola, either an upside down or a downside up, right? This kind of parabola is called minimum turning point parabola. This is max turning point parabola. All right. Now, a lot depends upon this a here. So let's say if I start to increase a, so let's say if a becomes hypothetically 2 or a 3 or a 4 or a 10, what will happen? Let's say this was my regular parabola. Let's say this was y equals to ax square, right? So let's say this a would have been not ax square, probably x square. That means a equals to 1, correct? Now if my a is 2 or 3, you know what will happen? The graph starts to become squishier and squishier and squishier. As the value of a goes up, the graph will start to pull itself closer to the y-axis. But then if my a is between 0 and 1, so that means if a is a fraction, let's say half, or 1 by 3, or 1 by 4, or 1 by 5, and so on, then if I redraw the graph of y equals to x square, let's say this was the graph for y equals to x square. Now, if x is half, you know what's going to happen? It will start to dilate outwards. And if you go on increasing a, it'll keep on dilating. It'll keep moving out. So this is how a behaves. There's one more fashion a behaves. Is this clear so far? There's one more fashion a behaves. So if my a is less than 1, that means a negative value. So if that's your y equals to x squared, you know what's going to happen? This graph will, let's say a was -1, let's say. So your equation y equals to x squared will actually be y equals to negative x squared. So y equals to negative x squared will be this graph. It will reflect in the x-axis. It will reflect in the x-axis. Right, so that's the basic, the very basic of the parabolas. Now, let's talk about another graph, which is, let's increase the value. Let's say n equals to 3. So now we're talking about y equals to a x cube. This is a cubic. Now, how the basic graph of cubic looks like? The basic graph of cubic looks like this. This is y equals to x cube. That is the point where the graph slightly, takes a twist and keep moving upwards, right? So this was moving up, kind of take a twist, and then keep moving in the same direction where it was moving earlier. This point where it takes that slight curve is called point of inflection. This is called point of inflection. This also happens to be the x-intercept. So at x equals to 0, the graph has a point of inflection. How do I find the intercepts? Y, if I say x-intercept is y equals to 0. That means 0 equals to x cubed, which means x equals to 0. This is what it is. All right. Now, if I increase the value of a, let's say I say a equals to 2. So the equation becomes y equals to 2x cubed. So what will happen? Exactly same as parabola. You see what has happened. It will squish itself towards y-axis. And let's say my a is 3. So y equals to 3x cubed. It squishes even further. Not great. Cubic. Maybe something like this. Right? So this is how it's going to be. Oh, good. Now, another point. If, let's say, my a is a negative value. Let's say a is -1. So my graph is y equals to negative x cubed. So if my original graph, if I draw my original graph, this is how my original graph was. Y equals to x cubed. Now if I have a minus, it is reflected. So this is how it's going to be. Right? This is how it's going to be. Not a perfect cubic, but they are mirror images of each other. This is x and y, right? This is y equals to negative x. All right? Oh, good, cool. Now we'll talk about the last point here, which is n equals to 4. So when n equals to 4, my equation is y equals to ax raised to the power of 4. Now this is a quartic. Quartic. Quartic is very similar to quadratic, where quadratic is more like this. Quartic is very similar, but it's a it's a deeper U. The bottom of the U is really deep and flatter, where the quadratic has a very pointy turning point, or the bottom. Quartic, I mean, this is how the quartic graph will be, whereas parabola will be something like this. You see, this is pointy in comparison to this, right? So this is the quartic. Now, if you start increasing the value of a here, which is now a basically across what we've learned is called dilation factor. It is dilating, right? That means it's making the graph broader or narrower from the x-axis, from the y-axis, right? So if the dilation factor a is greater than 1, you know what's going to happen? This graph will start to the bottom will start to become even more flatter. If you start increasing the value of a, it's going to have a wider base, right? And the rule for reflection stays as is. If your a is less than 1, so if I say y equals to, let's say a is negative 1, so I've got y equals to negative x4, so this is how it's going to be. So these are in general 4 different types of very commonly used graphs in the world of algebra, right, with all their properties. Hope that makes sense. Cool, thanks.